Okay. They gave us the equation of the 3x. Hold on now. Let me just remove this. 3x log of 2. Remember, when you see log by itself, it's assumed that it's base 10, right? Plus log, oh my gosh, log of 8x is equal to 2. So can anybody tell me, even if you didn't finish, can you tell me what you did first? Anybody?
It's I put 3x as a power of 2.
Okay, so you did this. Log, hold on. 3x. That's what you have?
Yes, miss.
Okay. And what was the rest of the equation? The same thing, log of e to the power of x equal to?
Yes, miss.
Okay. How much weight? Mouse plus log of a to the x is equal to 2. Okay. What did you have next? Did you get past there? Past this line? You have anything after this? Yes, no? No. Okay, I'll take that as a no. You just had these two lines?
Oh, no, miss. Then I multiply 2 to the 3x and 8 to the power of x.
Okay, so you have log 2 to 3x 2 times 8 to the x. Okay, and you have this equal to 2?
Yes, miss.
Okay, what did you have next?
I wasn't sure what to do, but I expressed 8 as 2 to the power of 3.
Okay. They have log of 2 to the 3x. Oh gosh. 3x times 2 cubed. Did you have 2 to the power of 3x or you have 2 cubed to the power of 3x? So did you have what?
I had 2 cubed and then to the power of x.
Okay. And this is equal to 2. You got anything after this?
Oh, no, miss.
Okay. Anybody had this? Well, anybody else had this? No? You had any of these lines at all?
No, miss.
Okay. Did you have something else or you just didn't know what to do?
Miss, I didn't know what to do.
Okay. Okay, well, so far you're going right. So let me just say that. Why? Because we said the two rules. So let me just write it out because seeing some unfamiliar names there. So that probably means you knew, and yeah, you wouldn't take. So we said when solving log equations, there are two rules, not laws. I'm not referring to the laws of log. I'm referring to the rules to apply when solving log equations. We said there are two rules. One is if you're given the log form, So, and we said this is log form. Log of x to the base a is equal to n. We said if we're given log form, then we can write it in exponential form, which is with that's an n, which looks like this. Or we can apply this rule, which states that log of n to the base a is equal to, well, if we're given log of n to the base a is equal to log of m to the base a, then we can say that n is equal to m. So what we said when you're given a log equation and you're asked to solve it, what you need to do is look at your two rules, so this one and this one, and you need to determine which rule do I have to apply here. If you look at the equation that you're given, none of these rules would apply right now. Why? Because I see two log expressions on this side, and then I see a constant on the other side. None of my rules talk about two logs being on one side and then a constant being on the next side. No. I see one log on this side and then a constant, and then I see one log on this side and one log on this side. So what you are supposed to do, you are supposed to simplify this to get it in this form or get it in this form, right? Because that's the only way you could solve a log equation. If you have it in this form and then write it in exponential form, or you have it in this form and then you could say n is equal to m. So what you're supposed to ask yourself is, how am I going to get this equation like this or like this? Well, you simplify. You simplify using the laws of logs. We know a law that says, oh gosh, my mouse again. We know a law that says n of log m to the base a is going to give me log of m to the power of n and this to the base a. And that is the rule I can apply here. I would take this, because I just remembered something was here. What this rule did, it just took the number that was here, brought it across, and put it in the power. See? It just brought this number across and put it here. Put it here. So that's what you're doing here. You see this number, 3x, you're going to take it, and you're going to put it as a power. And that's how we got log of 2 to the 3x, right? Now we have plus log of a to the x is equal to 2. My problem is, I still don't have it in this form. I have two logs on one side and then a constant on the other, well, a number on the other side. My rules talk about log on one side and a number on the other side, or log on this side and log on this side. So we know that this isn't in the form that we want yet, right? We have two logs on this side and a number on this side. What our aim is to get it in this form or in this form. So we know that we could simplify further. How do I simplify this? Well, I also know a law that says log of n to the base a plus log of m to the base a. Okay, I wouldn't write it out because I have no space, right? But it says log of n to the base a plus log of m to the base a is going to give me log of n multiplied by m to the base a. If anybody needs me to write that out, let me know, right? Is what we were doing before. But if you need me to write it out, I would write it out. And that's the rule we applied here. You see log, they add in. Hold on. So, and they have the same base. Remember, when you see log by itself, it's assumed that it's to the base 10. So because they have the same base and they add in, I can apply my rule. And the rule says log of n to the base a plus log of m to the base a is going to give me log of n times m to the base a. What does that mean for me? Log of 2 to the power of 3x plus log of a to the power of x is the same as saying log of 2 to the power of 3x times 8 to the power of x. and this is still equal to 2. Okay. Now we do have it in a form that I can use. I see log on this side and then a number on this side. You're supposed to realize that this is your log form, this form, and this is what I would use. Remember, this is 10, right? So this right here is in this form, and that's why I would use this rule right here to solve this particular equation. Right. So what can I do now? Everybody following so far? I need to ask that.
Yes, ma'am.
Okay. I need to erase, right? So erasing this. So what she did, she started simplifying this one time, right? But you don't necessarily have to do that. You could, nothing's wrong with that. She started simplifying. That's cool. Or, let me show you the alternative to that. Erasing this. So like I said, she started simplifying the 2 to the power of 3x times a to the power of x. She started simplifying it already, right? But you don't necessarily have to do that. We said we're going to write this in log form, right? So, mouse, come on. Hold on now. Okay, sorry about that. So you could start simplifying one time, or you could say, okay, for this particular log equation, I said I'm going to follow the first rule. The first rule is the one where I'm given the log form and then I write it in exponential form. So I can write this here, this as 10 squared is going to give me the 2 to the power of 3x multiplied by the 8 to the power of x. Everybody following so far? That's just the first rule I applied, right? Let me show you what you're talking about, just in case you're kind of confused about what I just said. No. I'm so sorry. I didn't mean to. So, this is what we have so far. Equal to 2 to the 3x times 8. And the rule I use for that one, so hopefully you wrote it down somewhere when I was explaining it so you understand what I'm referring to right now, is this one. I said I'm going to apply the first rule when solving this particular log equation. And the first rule is, given the log form, which is this, is equal to n, I'm going to write it exponential form. And that's what I did. This is my exponential form now. Here, now we can simplify. Because this right here, this is nice. 2 to the power of 3x times a to the x. What is that? I could simplify that because I can't really do anything with that right now. How do you simplify that? Well, that's why you see surds, logs, and indices. That's why they're considered like one topic. Because you see, surds, logs, and indices, they're all connected, right? So that's why they're kind of considered one topic. Right now, what you need to do is apply the laws of indices in order to simplify this. This is going to give me 10 squared. 10 squared is equal to 2 to the power of 3x. And then 8 can be written to the base 2 as well. 8 is also known as 8 is the same as 2 cubed. Cube to the power of 5. Right? So this is just me simplifying. This is no longer logs. This is basically indices now. What does this give me now? So I could put monthly to the train. But how do you simplify this? 2 cubed raised to the power of x. Well, see these topics? Indices, surds, and logs. You have a whole set of rules. A whole set of rules that you need to know. When we're doing indices, I told you about this rule, a to the power of n, and this whole thing raised to the power of m is the same as saying a to the power of n times m. So nm, it means the same as n multiplied by m, right? So how does this help me? Well, according to my rule from the laws of indices, 2 cubed raised to the power of x is the same as saying 2 raised to the power of 3 times x, which is 3x. Everybody following so far?
Yes, miss.
Yes, miss.
Okay. Anybody has any clue what I would do here now? Remember, what we're trying to do is solve for x. So what do you think I would do now? Anybody?
Would you add the powers?
The powers, yes. Well, you could add the powers. So yeah, okay. You could add them if you want to. Should I? Okay. Well, you're talking about adding the powers, so let me just write down what you said, and then I'll show you another way. So 10 squared is equal to, remember, this is also another law of indices. So like I said, you see those 3 topics, indices, surds, and logs. They're all connected. You need to know all of those laws. Don't mix them up, because it's easy to mix them up. You can't mix them up. Don't mix them up. Okay. So we also know a rule, I mean a law from indices, which says a to the power of n multiplied by a to the power of m is going to give me a to the power of n plus m. So what does this mean? When I have the same bases, when multiplying them, I can add the indices. I have the same base. I have 2 and 2. And they're multiplying. So I could apply this rule. According to this rule, what I'm going to do is add the indices. So if I add the indices, can anybody tell me what I would get? If I apply this rule, what would I get?
Miss 2
Anybody?
to the power of 6x.
2 to the power of 6x. Good job. 2 to the power of 6. Everybody following this so far?
Yes, miss.
Yes, miss.
Okay, that's 2 people. What about the others?
Wait, miss. Repeat again, miss.
Repeat which part?
Miss, I get 6, miss.
Look at this rule. When we were doing indices, we came across this rule. When I have the same base, and I'm
Oh, you
multiplying.
add them.
Add.
Oh, yeah. Yes, miss. You add them, yeah.
Okay, nice.
Oh, fuck.
So, now that we all on the same page, this is something I need to teach you as well. It's a part of your syllabus objective. It's the second one under logs. What? Remember when we were doing, well, the people who were with me, when we were doing exponential equations, solving exponential equations, what we said is that we need to put each one of them to the same base, right? People who were with me, you remember that? When I said when solving exponential equations, you need to make sure that they're to the same base. Remember that? Yes, no?
Yes,
You don't
Miss.
remember?
Yes, miss.
Okay. Well, what if, this is what I'm supposed to teach you now, right? So what if I cannot, like I just cannot write the both of them to the same base? I'll show you the note for that after, right? We said when solving exponential equations, in order to solve them, we need the same base. So let me just show you an example for the people who weren't here with me and for like people who need a refresher. Ignoring this whole thing, right? I just showing you an example now of what I'm talking about. If I have 2x is equal to 4, and they want me to solve this exponential equation, right? What we said is that we need to make sure both sides of this equation have the same base. They don't have the same base right now. I see a 2 here and I see a 4 here. So what I told you to do, you need to think about how exactly can I write both sides of this equation to the same base? That's what you should be thinking about. And what you would say is that, okay, I have 2 to the power of x, and 4 is the same as 2 squared. Now that I have the same base, which is 2 and 2, I can equate their indices. What I mean by equate their indices, just put their indices equal to each other, right? Therefore, if this was my question, x would be equal to 2. But this is where the logs come in. What if I just cannot write both sides of the equation to the same base? You see 2 to the power of x, I could write 4 to the base 2. 4 is the same as 2 squared. But if you look at this example, how are you going to write 10 squared and 2 to the power of 6x to the same base? Can anybody answer that for me? Do you think that I could write 10 squared and 2 to the power of 6x to the same base? Yes or no? If you don't understand what to say, let me know. I would explain. Do you think I could write it to the same base?
No, Miss.
I have one no. Anybody thinks it's no or thinks it's yes? Let me know. Yes or no? That was one person telling me no. Going once.
Miss, I'm not sure. Miss.
Okay, well, let me tell you the answer. No. It is going to be very difficult to write 10 squared and 2 to the power of 6x to the same base, right? What I mean by base, just in case anybody forgot, the base, when I refer to the base, I'm talking about this number, right? See this number right here? This is called base. And then this is called the power. Base, power. So we did that when we were doing indices, right? And what I'm telling you now, it's going to be very difficult to write 10 squared and 2 to the power of 6x to the same base. And that is where my logs come in. What you can do is, so this is the rule. When you have to solve an exponential equation, but you just cannot write both sides of the equation to the same base, or like it's very difficult to, what you would do is add log to each side. Can I erase this? I don't want to have too many things on the screen when I show you this.
Yes, Miss.
Okay. So the exponential equation I just had was 10 squared is equal to 2 to the power of 6x. And we said it's going to be so difficult, or maybe impossible. I don't know, I'd have to check And that'll take a very long time. To check to see if I can write both of them to the same base. We said no, that's gonna take long, or it's probably impossible. I don't know. You would have to sit down and actually check to see if that's possible, right? So what do you do in this case when you have an exponential equation but you cannot write them to the same base? What you do, I have a note on this as well, so I'll just show you right after, right? What you do is add log to each side of the equation. So I would get log of 10 squared is equal to log of 2 to the power of 6x. So I need you to remember that, right? When solving log, give me log now, exponential equations, but you just cannot write the two sides of the equation to the same base. What you do, what I want you to do is add log to both sides of the equation. That's going to help us solve for x, and I'll show you how, right? I just need you to know that right now. Remember we said, when we see log by itself, it's understood that the base is 10. So, oh gosh, it's understood that the base is 10, right? So by just putting log, it's understood that my base is 10. Base is 10. Okay. Now that I have this log equation, I could solve. I could solve for my x. How? How exactly do you solve for x, miss? Well, look at this, right? Oh, hold on. The mouse. I can rewrite this equation like this. We know 10 squared, that's 100. So I'm just going to put log of 100, right? Is equal to log 2 to the power of 6x. Remember, the base 10 is understood, right? I'm not going to write base 10 the whole time. I could just put the log. Our aim is to solve for x, but let me show you what's different about this question. I got my mouse. Remember I told you when solving log equations, you would use one of two rules. When you see the log form, you would express it in the exponential form. Or if you see log on both sides, then n is equal to m. You remember that?
Yes, miss.
A is equal to log of m to the power of a. And then we said this is going to be n is equal to m. But if I apply that rule here, I could apply that rule here, right? Because I have log on both sides and I have the same base, remember, base 10, base 10. So I could apply that rule here and get 100. Okay, let me not use red. I only use red for the formula and all that. I'm gonna use a different color. If I apply this rule here, I would say 100 is equal to 2 to the power of 6x. But how does that make any sense? If we're trying to get away from this, right? I just wanted to show you. If I'm trying to get away from this, I'm trying to solve this. Why would I come back and put the same thing here? It doesn't make any sense, right? This is what you do for questions like these. Wait, everybody understand what I mean? The purpose of me putting the logs here is so that I could solve x. Why? Why am I putting the logs? Because I said I just cannot write 10 squared and 2 to the power of 6x to the same base. So if I said I can't do that, why would I come back and write the same thing here? I would just be stuck. Everybody understands that?
Yes, miss.
Okay, so this is what you do for questions like these. Just letting you know, I have a note on it. So yeah. My mouse again. So this is what you do for questions like these. Let me erase this. So we already said it makes no sense to apply that log rule there. Why? Because we're just going to end back up with the same thing. And the purpose of us putting this log is to get rid of that. We're trying to solve for x. We don't want back that same thing. No. So this is what you do. Okay, this is what you do. This is what you do. We know a log rule that says n log of m to the base a is going to equal to log of m to the power of n and this to the base a, right? That's a law that we know, a log. One of the laws of logs, right? I can apply that here. Look at this, right? That's why I said it's a little different than how we did the others. I would say this is the same as log of 100 is equal to, if I apply this rule here, log of 2 to the power of 6x, that's the same as saying 6x times log of 2. Remember, our aim is to find x. We are aiming to find x. So what can I do to get x by itself? How exactly am I going to find x? Well, I could say now that log of 100 divided by log of 2 is going to give me 6x. Like, you know, when you're transposing means to make something the subject of the formula, right? And if I have, oh gosh, hold on. This thing. Remember, when you're transposing just means to make something the subject of the formula. I'm just showing you an example to show you what exactly I'm talking about. If I have 10 is equal to 2x, and I want x, yes. If I have 10 is equal to 2x, and I want x by itself, wouldn't I divide both sides by 2 to get x by itself? So I'll say 10 divided by 2, 2x divided by 2, this would cancel, and this will give me 5. So 5 is equal to x. Isn't that how we solve for x? Well, usually when we give a linear equation. Yes or no? Yes, no? You understand what I'm saying? If not, let me know. I'll explain it a different way.
Miss, I kind of understand.
If I'm given 10 is equal to 2x. Use another example. Forget this question for now. Forget this whole thing. Erase it from your mind. Don't study that right now. That's not what we're doing. I'm trying to make you see something. If I told you that 9 is equal to 3x, what would be the value of x here? X would be equal to what? X would be equal to what? Nobody knows what x would be equal to.
It's 3, miss.
3. And how did you get that? Yeah, how did you get that?
I don't want to explain.
Then I'll explain it. Okay. Well, we all agree that the value for x would be 3. Yes or no?
Yes, miss.
Okay. Can anybody explain to me how you got 3?
Maybe 3 times 3 is 9.
Wait, so all you're just learning off things for learning its sake. You don't understand what you're doing. Anybody understands how we get 3 as the answer for x?
Miss, is that a 9 or a?
That's a 9.
We said divide both sides by 3.
Exactly. Okay, so I need you to remember, don't just learn off things for learning of sake. You need to understand what you're doing, right? So you need to understand why you get x is equal to 3. You divide both sides by 3, right? This is what we're doing here now. Hold on. Same concept we're using here. We need to find x. Why did we divide both sides by 3? Because we needed x, right? Same concept here. So let me just erase this real quick. Erase this purple. I want x by itself. How exactly am I going to get x by itself? Well, just like we did with the 9 is equal to 3x, what you have to do is divide both sides by log 2. Why are we doing that? Because our aim is to get x. We want the value of x. So we need to get everything. You need to get rid of everything around x, right? Because we just want x by itself. That's what we're trying to find, the value of x. Just like when we had 9 is equal to 3x, to get the value of x, we needed to divide both sides by 3. It's the same thing in this case. I want x by itself, so what I would do is divide both sides by log 2. When I do that, what's going to happen? This is going to cancel with this. And what do I remain with? Log of 100 divided by log of 2 is going to give me 6x. Everybody understands how I got this now?
Yes, miss.
Yes, Miss.
Okay, next. Glad that example helped. Okay, but there's still a problem. We have what 6x is, but we don't want 6x. We need to find the value of x by itself. So we do the same thing. Just like when I had 9 is equal to 3x, and I wanted to find the value of x, I divided both sides by 3. Why did I divide both sides by 3? Because I needed to get rid of everything around x, right? I needed x by itself. We're doing the same thing here. Because I have log of 100 divided by log of 2 is equal to 6x. I need to get rid of this 6. How exactly am I going to get rid of this 6? I do that by dividing both sides by 6. And that is how I would get the value of x. Okay, I'm going to end this, rejoin, so I can just finish this question, and then you could